Hello all, welcome to the video lecture on signals and systems. We are discussing about Fourier transform, and this video would be on problems on Fourier transform. We will discuss a few basic problems on how to apply Fourier transform for a few particular signals. Moving on, determine the Fourier transform of the continuous time domain signals. There are two questions here, and I'll be solving one for you in this particular video. X of t is equal to 1 minus t square for t less than 1, 0 for modulus of t greater than 1. So we will pick this question A first, and we will try to apply the Fourier transform. So by the definition of Fourier transform, what is x of j omega? X of j omega is nothing but integral minus infinity to plus infinity x of t e power minus j omega t dt. So now what is your x of t? 1 minus t square. So 1 minus x of t will have a value of 1 minus t square only for modulus of t less than 1. So which means that from value minus 1 to plus 1, the value is 1 minus t square. So we will change the integral limit as minus 1 to plus 1. We substitute 1 minus t square e power minus j omega t dt. So the next point is we will have to start with integration. So before starting with integration, let us split this sum. So we will have the constant 1 in one particular integral and this t square in the next integral. So as you can see here, e power minus j omega t dt integrated between the limits minus 1 to plus 1 minus integral minus 1 to plus 1 t square e power minus j omega t dt. So this is how we are going to have it now. So now, as you can see here, I have a few terms here. Now let's check how we have actually arrived at this. Now if you can look at this, integral minus 1 to plus 1 e power minus j omega t dt. This is a very simple integration which will give you, look at the first term, e power minus j omega t by minus j omega between the limits minus 1 to plus 1. But look at the second term, integral t square e power minus j omega t dt. We have a multiplication here, and integral of this particular will actually yield this one. So we will actually check in the next slide how we have got these two terms on integrating this t square e power minus j omega t. I will exactly tell you only this particular integral in the next slide, and then we will move on with the particular problem. So look at that. So this is your basic expression, e power minus j omega t dt minus t square e power minus j omega t dt. So this first integral we have already solved and we have already got an answer, and we are into this one, t square e power minus j omega t dt. So taking this, this will actually come under this particular form, which is u dv equal to uv minus v du. We will have to work on this particular formula to arrive at this particular integral. So what we will do is your u will be taken as t square and your dv is nothing but e power minus j omega t dt. So from u, you will have to obtain du, so which is nothing but 2t, and from dv integrate this to yield v. So which is v equal to e power minus j omega t by minus j omega. Now next what we will do is we will find out what is t square e power minus j omega t dt integral minus 1 to plus 1. So simply substitute. Look at this. You have uv. So this is your this expression. U is t square and we have put t square. V, what is v? E power minus j omega t by minus j omega, and we have got it here. So there ends your first term. So what about the next term? Integral v du is this one. So what is v? V is e power minus j omega t by minus j omega. So we have your v here. And what is your u? I mean what is your du? Your du is 2t. So then you have your 2t dt, which is nothing but your du. So integrating between the limits minus 1 to plus 1 throughout. So this same statement is what given in the next step. I hope you all have understood what or how we have calculated this particular integral t square minus e power minus j omega t. So moving on to the next slide. So that's it. We have it here. So e power minus j omega t by minus j omega between the limits -1 to +1. And here we have the terms which you have calculated using UV formulae. T square e power minus j omega t by minus j omega minus integral 2t e power minus j omega t by minus j omega dt. Now next what we have to do is substitute the values of -1 +1, and also you'll have to integrate this particular part. So we will see how this actually goes. Look at only the second term and the third term. The first term is kept unchanged. So the second term, t square e power minus j omega t by minus j omega, I've kept the same here. We will integrate the third term here. So when you integrate this last term, what will you get? E power minus j omega t by minus j omega. So minus j omega and 2 is a constant here. So 2 by j omega we have taken outside. So inside the integral, what do you have? T e power minus j omega t dt. Now in turn again we will have to apply the same integral of UV formulae. So once you apply UV, you take your u as t and you take your dV as e power minus j omega t. So going on, you will be able to arrive at these two expressions. So here, as you can see, this particular integral will actually split up into So now look at this. The first term remains the same and the second term also remains the same. We will just check out these two terms alone, what happens after applying the UV formula. So 2 by j omega is the constant here which is kept outside. So after applying UV, your u is t and v is e power minus j omega t by minus j omega. Integral v du is this part, 1 into e power minus j omega t by minus j omega dt. So throughout this integral, we will have to substitute the limits -1 to +1. So in the next stage, we look at what happens here exactly. So this is a previous step what we have seen, and this is actually resolved here. And if you can see here, the first term remains the same, second term remains the same. Just look at the third term and the fourth term alone. So this is your third term. So 2 by j omega is here. You have another j omega here, so bring it outside as common, so which becomes j omega whole square, and you have it inside the bracket as minus t e power minus j omega t plus we have already brought j omega outside as common, so you will have it as integral e power minus j omega t dt. So now this is actually between the limits -1 to +1. So minus e power minus j omega t by j omega between the limits -1 to +1. First term remains the same. Second term also remains the same. But just check what has happened to the third term and the fourth term. Your third term is 2 by j omega whole squared. So what is j? J is j squared is -1. So then you substitute it as minus here, and it has become 2 by omega squared. Minus t e power minus j omega t, it remains the same. So integral e power minus j omega t dt. On integration, what has happened? E power minus j omega t by minus j omega. Now we will substitute the limits in the next step. So this is your previous step we have already seen. Now we'll see what happens here. The first term remains the same, there is no change. The second term also remains the same, there is no change. Look at the third and the fourth terms around. So we will multiply 2 by omega squared inside the multiplicative bracket. So when you multiply, you will get it as plus 2t e power minus j omega t by omega square plus 2 e power minus j omega t by j omega cube. So this way here, we will substitute the limits. We have almost refined all the terms and we have actually brought it to a very closer point. So let's substitute the upper limit and the lower limit. So the point is upper limit minus lower limit. Wherever you have t, you will have to substitute the values of the limits. So if you can check here, minus e power minus j omega t by j omega. Let's substitute e power, you will have to substitute the limits. So first you will have to substitute 1, then you will have to substitute -1. So you will get it as minus e power minus j omega by j omega plus e power j omega by j omega. Why this has become plus? upper limit minus lower limit. So minus into minus will become plus. So now look at these three terms. For all these three terms, we have to substitute 1 and minus 1. So you can see 6 terms here. The first 3 terms, we have substituted 1. In the second, the last 3 terms, if you can see, the lower limit minus 1 is substituted. I have marked you for your reference here. So let's check. We will first substitute 1. So where you have to substitute the limits? Wherever you have t, you will have to substitute the limits. Why we will have to substitute in place of t? Because the entire integration we have done in terms or with respect to the time t. So wherever you have t, you will have to substitute the limits. So let's start. Minus t squared e power minus j omega t. So substitute 1 here. This will become minus e power minus j omega by j omega. Second, this term 2t e power minus j omega t by omega square. Substitute 1. What will you get? 2 e power minus j omega by omega square. Now this third term, we will substitute 1 here. 2 e power minus j omega t by j omega cube. Substitute 1 here, where in the powers of e. So what will you get? 2 e power minus j omega by j omega cube. So we have substituted the upper limit minus lower limit. So minus the lower limit. If you can see, all the last 3 terms are multiplied by minus. So the first term is negative. So we have made it as positive. Similarly, the next 2 terms. So now let's check it. We have it as minus t square e power minus j omega t by j omega. So you have your t value as minus 1. So then we substitute it here. What happens? T squared. So which is minus 1 squared. We have got it as e power j omega by j omega. So if you can see, the second term, this is also having a positive sign. This is also having a positive sign. In spite, we have multiplied by negative. How this has become positive? Look at this. 2t e power minus j omega t by omega square. So we have a t here. When you substitute minus 1 here, what happens? You get this term as negative. But when you substitute lower limits, another minus sign is there. So then that's how this has become positive. 2 e power j omega by omega square. Look at the last term. 2 e power minus j omega t by j omega cube. So we have got the negative sign here because upper limit minus the lower limit. So that minus sign is this one. When you substitute minus 1 here, what happens? E power becomes positive. 2 e power j omega by j omega cube. The next step, what we'll have to do is, can you see a minus sign here? We'll have to multiply the entire, all the 6 terms with this minus. So we'll see what happens. This is the previous step we have seen. Look at the below step. We have multiplied all the 6 terms with minus. And then we have got this particular step. So this particular step we have got by multiplying by minus sign. So then what happens next? We'll have to check for the common terms and we'll have to cancel it out. Look at the first term. First term is e power j omega by j omega plus e power j omega by j omega. Look at this first term. Check if there is a corresponding term for this. Look at this third term. E power minus j omega by j omega. This is negative first term. Third term is positive. So then we will simply cancel it out. Now look for this one, e power j omega by j omega. This is positive here. Look for a negative term, and yes, we have it here. Minus e power j omega by j omega. So cancelling out both. So the balance what we have are, look at this. You have 2 e power minus j omega by omega square. Also you have 2 e power minus j omega by j omega cube. Then you have minus 2 e power j omega by omega square. And then you have 2 e power j omega by omega cube. So if you can clearly see, look at the denominators. You have omega squared, j omega cube, omega squared and j omega cube. So pick the omega squared as common. So this one and this one goes here. Just check this. We will bring out 2 by omega squared as common from these two terms. So what is there left out? E power j omega plus e power minus j omega. Similarly, the j omega cube terms. We will pick out 2 by j omega cube as common. So the left out variables are e power j omega minus e power j omega. So this is of form sin theta cos theta. According to the formula, this becomes sin theta is equal to e power I theta minus e power I theta by 2i, and cos theta is e power I theta plus e power I theta divided by 2. So we will substitute this here. So when you substitute it here, just look at this. This is cos term and this is sin term. So this becomes 2 cos omega and this becomes 2j sin omega. So what next? Multiply the variables and get the final answer. You get it as minus 4 cos omega by omega square plus 4 sin omega by omega square. So we will bring out 4 and omega as common. You will get it as sin omega by omega minus cos omega. So I hope you have understood how you will have to solve the Fourier transform problem. So while solving the Fourier transform problem, it is not only important to apply the formula properly, it is also important to know a few trigonometric formulas so that it would be very much helpful. Now those trigonometric formulas we have used in this session are very common formulas which you will use repeatedly in any Fourier transform problems. So make sure you memorize them. Thank you.